afternoon, everybody. Thanks for joining me again here today. This is going to be a little different than malware analysis fundamentals. What we're going to be looking at today is actually a CrackMe. So this will be part of the CrackMe series. Now, if you're not familiar with these, they are challenges that are generally created by other analysts, be it a malware analyst or somebody who dabbles in reverse engineering of software. And they're just like little challenges, kind of like hack the box, that allow you to sort of sharpen your skill set. Today we're going to be taking a look at a binary called CrackMeIdiot, and it is a .NET executable, so we'll be using a couple of specific tools for that. .NET executables differ a little bit from your standard C or C++ executable in that Ghidra and the like are basically useless to debug them. They don't show pretty much any code that's going to be of value to us, and I may illustrate that here within this video. But first, we're going to take a look at some of the behavioral analysis of the program so we can figure out what exactly it is we're supposed to do. So first, we'll go ahead and open up CrackMeIdiot and see what we're supposed to be doing. Okay. So with CrackMeIdiot open, we can see that it is expecting an email address, a serial key, as well as a CAPTCHA. So it looks like the CAPTCHA in this case is a static image that's been embedded into the form that's been created with .NET here. We don't know what the serial key is, and we're not sure what email it is expecting, but let's just go ahead and click the register button. Apparently we are a bad boy, and we did not fill the text boxes, or our key is invalid. So sometimes with things like this, you can get a quick win just by running a utility like strings on it. In this case, I don't think that's gonna work. We'll go ahead and open up a command prompt. Oh, that's not it. Just cmd. And in case you haven't noticed, this video is going to be a little different than the other ones in the sense that it's going to be a little more stream of consciousness, just because it's hard to have a prepared sort of show to go along with when you're doing a challenge such as this one. So we'll go ahead and cd to the desktop here, and let's just run floss on it. Okay, looks like we've got several strings. Here we can see our good boy message as opposed to the bad boy message. We also see the text here from the CAPTCHA message from before. We can also see an email address, which is lol@lmao.wtf. So we'll go ahead and copy that, and when I'm doing a challenge like this, I like to generally keep something like Notepad++ open just so that I can keep notes of anything useful that I've come across within my reverse engineering attempts. We'll also go ahead and copy this out. And as you can see, there's like a little hyphen here at the end of the key. So I'm guessing that this is not going to be the full key. So I don't think strings is necessarily going to be the answer here. What I'd like to do now is I'm going to go ahead and cut forward a little bit since we didn't get much from the strings. And I'm going to open it up in Ghidra and try and display to you exactly why Ghidra is not particularly helpful in this situation. Okay, so what I've done is I've created a new project in Ghidra, imported the binary, and then begun running it through the auto analysis feature of Ghidra. Now, generally, if I were doing a C# binary, or I'm sorry, a C or C++ binary, my first step would be to kind of just start scrolling through the code here and just seeing if anything stands out to me as interesting, just sort of looking at the functions that exist within the code. However, just by starting to scroll through here, you can see that there's really not a whole lot going on. I think we just saw the PNG image that is imported for the, yeah, there it was, for the CAPTCHA. So we see Saplebeam there again. And keep scrolling down. Looks like we've got some strings within this particular section of binary, but really it's not as much as you would see in your standard C or C++ executable. I do see some interesting sections here within the code. Look like they're fairly randomly named, which is consistent with an obfuscation technique. Looks like there's some stack strings built there, but they don't appear to be anything significant. Also see some other strings over here, and I guess my next step would probably be to go and look at the symbol references, which is going to be any sort of API call that's imported or DLL that's imported for functionality of a program, usually within C or C++ executables within the Windows environment. But even when I open that, you can see that there's an entry point and core.exe main, but that's pretty much it with a call to jump to a dword pointer to mscore.dll. That's the only call that we see here. So I don't think Ghidra is going to be particularly helpful, and as a rule of thumb, it generally isn't for .NET executables. However, there is a trick for .NET executables. When they're compiled, the code basically lives inside them, and you can decompile pretty much any .NET executable with the right tool set. So to that end, we'll be using a tool called dnSpy as opposed to any reverse engineering tools like Radare or Ghidra or any traditional debuggers like that. We'll be utilizing a .NET debugger instead. Okay, so I've opened up dnSpy or .NET Spy. So now I'm just going to open up our executable and we can start looking at some of the .NET code once we get it imported. So we'll just navigate to the old desktop here, get that running. Okay, pretty quick import. So we can expand this and take a look at the internals here. If we go and look at CrackMeIdiot 2, we'll expand that. So classically within .NET, we've got the form object, which is what we saw already within the functionality of it. It's the little message box there with the input fields as well as the images for the CAPTCHA. And then generally we'll also have a program, which is usually where the code lives. However, I do notice that I've also got a blank code object here, so that probably bears some looking into. So we'll look at that in just a moment. If we expand program, this is where we would generally expect to see the code, and we can see that there is a call to a main function here. However, it appears totally blank. So it doesn't look like there's actually any code housed within where we would normally expect to see the code. Expanding form, it looks like we've got picture box, which is to be expected with our CAPTCHA. We've also got the text box changed events, label one click events, again blank, public void IP, so it's not returning anything, but it doesn't look like there's any code there anyway. Got form one load event, nothing there. Button one click, nothing there, and nothing in form one load either. So it looks like we're totally devoid of code within where we would expect it to be. So let's go ahead and move on up to our curly brace here. Okay, so it looks like we've got some references to some strings that we saw within Ghidra, some randomly named binaries here, or rather some randomly named functions, it looks like. All right, so we've got 3 functions under this particular one. Some fairly complex crypto code. Looks like it's been purposely obfuscated. Getting processes by name with -x86. Interesting. Using a text2 variable to do that. That string appears to be dnSpy backwards, so it appears to be looking for the program that we're using. Looks like we've got a virtual protect function here. Don't know that that's going to be relevant necessarily. And then we've got another long complex function here. I'm not even going to attempt to guess what this is doing, but it does look like it's also looking for our process. If we go and look at the module section, we can see that first it's going to call this class and then this function within that class. So it's probably going to be wise to start there. And what we're going to do is we're going to set a breakpoint on that, I think, and then step into that function. and we'll probably just go through it step by step to see if we can see where exactly the serial number that it expects exists within the program. Hopefully it'll load that expected serial number into a variable or into memory at some point, and we'll be able to extract it and then utilize that to complete the challenge. Okay, so what we're going to do now is just right click on this first method call within the module, and we will add a breakpoint, and we will start debugging. And we should basically immediately hit that breakpoint, so here's hoping. And we have. Perfect. So what we're going to do now is we're just going to step into that function that's being called, and we'll just go through it step by step and basically see where things break and try and address them piece by piece. So let's just start stepping through some instructions. Okie doke, we are defining our module here. Fantastic. We're going to step over, and we're just going to keep stepping over stuff. Okay, so if the module fully qualified name is not, alright, we'll step over that. Good stuff. New binary reader. I don't know what they're doing with that, but we'll just play along, pretend like we do. That's fine. Looks like we're defining several things called flags here. So we've got flag 3. And there's probably going to be something to keep an eye on, I would imagine. So let's take a look. We've just hit a conditional here that's going to lead to environment.failFast broken file. So let's go check on flag 4 and see if that's true, because we may have to alter that. If so, flag 4 is false, so we can continue to step. And we're going to do some silly math here. Continue to read our binary stream. Looks like we're going to be doing this for a minute. So what we'll do is we'll just, and this is a great way to just exit a loop if you're not really interested in whatever the loop is doing and you don't want to sit here and watch variables for hours. Just go right outside of the loop. So in that case, we're really more interested in getting to this next conditional down here. So we'll just go ahead and I don't see anything making this exit. So we're actually just going to go, like I said originally, and we'll go right outside of the loop, as opposed to, we're just going to skip this conditional for now because I don't think it matters. So we will right click and let's add another breakpoint. And now we'll just continue. Anytime we do that, I cringe a little bit because I'm afraid I've missed something within the code that's going to make it crash out. But in this case, it looks like we did hit our next breakpoint. So this is again where we can see, looks like a reverse string of the title of our program here. So dnSpy, dnSpy backwards. So I imagine we're going to be iterating through some processes at some point and looking through this and then exiting if we find it. That's pretty common within malware. They utilize something like create tool help 32 snapshot. I don't think that's what they've done here. I don't even know if it's possible to do that in .NET. I imagine it is. It's probably just obfuscated through layers of Microsoft bullshit. But we'll just continue to step through at this point. I just imagine that's the technique or tactic that we've undertaken. So let's go ahead and continue to step. Defining a blank string, and it looks like in this particular loop here what they're doing is iterating through until they've actually reversed that string within memory. And we can validate that by going down here and finding the text2 variable, and there it is. You can see dnSpy or dnSpy has been reversed and loaded into that particular variable. Okay, so continuing to step through, looks like we're defining a memory stream. and then doing some other wonderful things, I'm sure. I think a lot of this is probably junk code that's just meant to divert attention, frankly. I think that's the thing that a lot of folks get caught up in, is that there can be a lot of meaningless code within a program, just put there basically to increase the amount of time that it takes to sort of dig your way through all of the garbage. And that's a tactic that adversaries use a lot in actual malware, is that they'll just put in garbage code that's totally meaningless just to increase the amount of time that it takes an analyst to find the true functionality. I've seen VBS droppers that were 80 megabytes, which is insane because they could have easily achieved that functionality in, maybe a few kilobytes, which is fine. I mean, these guys are really good programmers. They're doing that to purposely divert your attention and mislead you. So with that said, we'll just keep on going through here. It looks like we're reading some bytes and looking at a stream again, looking at the position that we're in the stream. Okay, so here we are. If you look at flag 8, flag 8 is get process by name, text2.length. If it's not 0, then we're going to write something to the memory stream. Otherwise, we will not. So flag 8, we definitely want to be false because it is trying to get the process by name of our current process, which is dnSpy. It's basically seeing if it's running at all, and it will not continue to run, I'm guessing, if that's the case. So we will just set flag 8 to false. So let's let it run through that until we get to the conditional. Okay, so we're if flag 8 right now. Let's go check flag 8. I'm guessing it's true. You probably scrolled past it. Where is it? There's flag 7. Flag. Yeah, I know you're in here somewhere. The sort by name doesn't seem to work within here, which is unfortunate because it makes it quite difficult to find what you're looking for. Flag 8. You guys are probably losing your mind because I've scrolled past it like 5 times. There it is. Okay, true. So we know that it has found our process, dnSpy. So we will actually just set that to false because we're going to lie to the program like a liar. So we'll just skip right over that. And boom, if flag 8, we passed that check. So it is not going to write that to memory. So scroll down a little bit within the menu here and we'll just keep on stepping. So making some numbers, adding some numbers. Not sure what we're doing here. All right, looks like it's checking again for our process. So we're gonna let it set that, and then we'll go back, set it to false. Interesting. Looks like we're looping through that several times. I'm just going to keep stepping and see what happens. Didn't seem to exit. I'll just keep going. Apparently we're creating an MD5 hash. Interesting. If flag 9 environment.exit, well, we don't want to do that. So we're probably going to lie to it. Let's go see what flag 9 is currently set to. True. No. How about no? We'll just change that var. And we'll just keep on going. Alright, so it looks like we're going to step into our other function here. We could step over this if we really wanted to, but I kind of want to step into it. just to see if we can figure out what is going on here within that second function. So let's just step right into that. So now that we've stepped into the function here, we can see that looks like there's some complex math operations taking place here. It also looks like we're going to be doing something with AES. You can see several references to that here, as well as some create decryptor kind of things. So I'm guessing that we're going to be decrypting something within memory using the CryptoStream API. If we scroll up, we can also see back where it was called that we're expecting array2 to be returned from this function. So it'll be interesting to see what we're returning within that array, I think. So it looks like we're going to be checking for the process again to see if we're being debugged. So let's just start stepping, I suppose. And there's our string. We're going to reverse that again. Gonna check for our process. Uh-oh. Through an exception. All right. Interesting. Interesting. All right. And this is the kind of thing that happens when you're doing these challenges, is that you'll chuck an exception somehow and you'll not really know why, just because you missed something somewhere. So we'll just have to see what we can do to bypass that. So let's go back and we will set, let's see where our breakpoints are. Get rid of this one. And I think what we'll do is we'll get to this one and we'll set a breakpoint here on our first conditional. So if you noticed, I let that return true a few times last time. So what we'll have to do is very carefully watch this and return it as false every time, and we'll see if that changes things for us. Uh-oh. Uh-oh. Houston, we've got a problem. Let's stop it and start back up. Perfect. So we hit our first breakpoint. We're going to continue. All right, here's a breakpoint. Let's find flag 8. It's true. We'll set it to false. I suppose what we really could do is just, let's try this. Let's stop the program here. Let's see if we can edit this. I'd like to be able to just put something in there that just says flag 8 equals false. Looks like it's in lowercase in C#, so we'll just say compile. It did not like that. Okay, that's fine. We'll just we'll do it the old-fashioned way. Okay, start back up. First break, second break. Let's go find flag 8. There it is. False. And while we're doing this, we just want to be absolutely certain that we don't hit this condition. So we'll add a breakpoint there too, and then we'll just continue. So we hit it again, false. We've hit it again, false. We've hit it again, false. And we're just going to repeat this until we hit our next breakpoint, really. Okay, so we hit flag 9. So let's go check flag 9. flag 9 is false this time, so we don't have to change it. So obviously letting that return true performs some sort of really gross thing to the memory stream that causes flag 9 to change its value and then exit the program. So it's not quite as simple as just looking for the process and exiting. It's performing some deeper method of obfuscation there that makes it more difficult for us to bypass that by calling that several times and then altering something within that memory stream that it's looking at. So I think that's probably, hopefully, why we threw that exception last time. Let's just keep stepping. Okay, so we will step over this again. And then we're going to step into the function that returns the array again. And we'll just keep on stepping. Here we are, hitting this again. Let's reverse this string again. I really don't want to deal with clicking through that. So I'm just going to add a breakpoint here. Hey, doesn't look like we triggered the exception that time. So clearly we figured something out. So we are looking at our process again. We're going to step over into the conditional. Our flag is true, but we're going to say it's false. And we're actually going to set a breakpoint here just in case it loops like the last one did. New random, that's interesting. So I don't know why it would be doing that, but it's okay. We'll just we'll continue execution here. I'm gonna step over that. Did I not set that to false? Shoot. Now this is what happens when you don't pay close enough attention, I suppose. So let's go ahead and stop debugging. That is what I get. So, as I said, I don't tend to cut out mistakes because, well, they happen a lot. So, we'll go ahead and start debugging again. And step into the first function. And we should hit our flag 8 breakpoint. And we're just going to step through this again once we find it. And we'll just keep setting it to false. But this time I will copy it so I don't have to keep typing it. So continue. 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 If flag 9, surely flag 9 is false. We really want it to be. Man, it's true. Okay. I think I messed up and didn't press enter at one point. So go back. Continue. Let's hit our flag 8. Okay. Perfect. 1, 2, 3, 4, 5. If flag 9 should be false. Scroll up. Where's flag 9? Flag 9 is false, as expected. So the next breakpoint we hit should be the one that we set on if flag. And we do. So we'll go find flag, set it to false, and then we'll just start single stepping again. Single step. We're creating a SHA-512 called SHA. Interesting. Repeating hash. Doing a loop. Let's just let's set the breakpoint on the return and let it run through its loop here because I don't see any conditionals that are going to harm us. All right, so we're going to return array. However, I'd like to look at array and see exactly what it is it's returning. It's distinctly possible that this function is really just an anti-debug function, and the interesting things are going to be done in the next one. We've discovered several anti-debug methods within this, so looks like it's just an array of hexadecimal characters. Don't see anything of interest there. I suppose it could be the serial key. We can always return to that if it is. We could copy out all of these values if we wanted, but we know how to get here, so we won't bother at this point. We're just going to keep going through in our first pass, or third pass, I guess, if you count the times I screwed up, and we'll just see if anything else interesting stands out to us. So stepping in, looks like we've returned. Okay, looks like we're gonna do that again, I suppose. Okay, copying some stuff. Back to our binary reader. Initializing a pointer. In a while loop here, it would seem. We've got a couple of calls to some internal functions here, which I think we're about to hit. Yeah, so array6.length, fl new protect. We can step into these and see if there's any anti-debug stuff in here that's going to harm us. Doesn't look like it. Oops. I see what I did there was I accidentally stepped into a function that is not a user function. It's a Microsoft DLL function. So let me step through this really quick and we'll return after that, because you really don't want to sit here and look at all of these really boring, dry Microsoft functions just to do some memory copying and things like that. So let me get out of this. I'll cut forward and we'll return back into the user code. All right, so now we're back in the userland code. Gonna keep stepping on through here. Just step over this. I did notice that we've hit a flag here, so I'm hoping that this flag is not going to change anything. It looks like num23 is called here, and it references a binary reader. I think we've pretty much managed to avoid messing with anything that's going to break that, but we'll see what that looks like. I'm actually going to set a breakpoint here so that we don't have to keep single stepping through. I'm actually going to move it down one so that we hit it as we exit the function. Perfect. So we'll continue to single step. Okay, step over that, step over that. So now we're going to get to the next function, it looks like. So we'll just step right into this. Okay, so we got all kinds of code here. And a function I don't know that we've seen referenced before. Okay, it's looks like a self-referential call. Let's go down here to the classes and we'll expand and see what methods exist within the class. So we're calling 1.7 first, and then we're calling the next one several times. All kinds of flags here. Goodness. Let's go take a look at this function. Lots of pointers. lots of defined variables. I think the best thing that we can do is continue to just single step and see what comes up. So we'll just keep on stepping. I'm gonna keep on stepping through this loop. I think now is probably going to be a good time to go look at our variables, see if anything stands out. Still lots of pointers. Let's just set a breakpoint at the end of the function. I don't think we want to do that one specifically. So I believe that, so okay, yeah, this is the function that we want. We've got that one, which is the virtual protect function. So we go down to the end of this one, and we'll set a breakpoint here because these are big long conditionals. Add a breakpoint there, and we'll add a breakpoint here. I'll just hit continue. Okay, so we've hit the end of that function. We're going to step over it. So for that one here shortly. First, I want to take a look at these bars. Nothing there. Nothing there. That's the end of our calls. Okay. 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 And then it opens. Interesting. Same. Okay. So clearly we've missed something. We'll take a look and reload and start back at the beginning and see what we've missed. Okay, so I think what's happened is got a little caught up in going very fast through our debugging process, which is not always good for you. So what we're going to do now is we're going to go back through step by step, and we're going to defeat all of the underlying mechanisms for anti-debug that we've seen looking for our program. We're going to change those variables to false, and then we're going to single step through the rest of the process until we get to the point where the application loads right after this highlighted function that you're seeing on the screen now. And then we'll go back through and examine the code, particularly for the button one click, because I suspect that's probably where the validation takes place, or at least a call to a function that does the validation, and then we'll look at that. So without any further ado, let's go ahead and get to our first breakpoint. Go ahead and get her started, and bam, we're on flag 8. So let's go to flag 8, and we'll iterate through this. I think it's 5 times, and we'll be sure to set our variables to false. Making sure this time to press enter after each one. Okay, so we've hit our next one, so we'll do false here as well. Then we're going to return our array. We'll start single stepping. Okay, so that is the call to the next function. So we will continue here. Gonna hit that breakpoint. Step over that, step over that. Okay, we'll step into this one. We can see some code population here. So let's start single stepping through this. This may take a minute, so let's just get going. Is there a hotkey for this? Yeah, F10. Gonna be a lot of clicking here. May cut out the audio for this part. Okay, we seem to have crashed out. So I'll get back to that point and meet you here. All right, so we're back. I've taken the liberty of clicking through that function for you so that you didn't have to watch me just single step through that the whole time and listen to my mouse click a whole bunch. So you can see that we are now within the application.start, which is just after these two functions. So we hit this function, defeated all of the mechanisms. You saw that part. It froze up here. I was able to get it to resume within this function, which we've taken a look at. This is this long iterative loop that looks at the stream that we generated in the previous function. And then we return to where we're currently at, which is where it loads the forms. So let's go back to where we're at. And we can see that, let's step out real quick. We're in this line right here, which is application.enable visual styles. We've got all of the code that we were looking at before, the long iterative function here that I clicked through. That's the only thing that you've missed. And then we've got all of the functions here that we defeated the stuff in. So now that we are at this point, I think we should have some code within our button1.click that either is going to point us to where our serial number is validated or validate the serial number right there. So we'll go take a look and see how that works. So let's go find our button. So it should be under form 1. And we'll do button 1 click. And would you look at that? Perfect. So we have, it looks like, here's our text box. So it's expecting that email that we found in the strings, sepal beam, and then a new object that's a concatenated string, it appears. So it looks like the serial number is going to be, okay, let's compare this to our notes. So that string dash environment.username, in this case, we'll just open up PowerShell here. Just want to make sure we've got the correct syntax here. And debug it again. So close this out. And now let's run it without a debugger attached so that we can actually interact and hopefully paste in this key and it'll work. So we know that it's expecting this email. So we'll just grab that, paste her in. We think this key is going to work. So we'll just paste that in. And then sepal beam is pretty easy to type, so we'll just type that and register. Hey, looks like we did it. Good boy. Now I write a keygen for this program. Generally, I'm not going to do that, but you know what? I'm going to give it a crack this time, and I'll come back with a working keygen. I'm going to write it, I think, just in PowerShell, because that seems like it's probably going to be the easiest way to go about it. So be right back, and I'll show you the keygen, how it works. Okay, so I have written a quick little keygen here. You can see that for the first two variables, we're accessing some environment variables and then loading those into variables. For the next one, we are taking the processor count using get CIM instance, and then we're loading that after expanding the property and accepting the integer there into a variable. And then we define our key as specified in the code that we looked at. And then we spit it out onto the command line utilizing that. So you can see I've copied it and pasted it into here. And when we register, again, we get good boy. So obviously our keygen works at this point. So I will say that we have successfully completed this CrackMe and written a keygen for it. So I think we're good to go there. Just to summarize what we've done today, we took a look at dnSpy and dug into a .NET executable, sort of single step through the code until we found the anti-analysis features that it was using to defeat our attempts to view that code. Once we got to where it loaded the form, we were able to view the code that validates the serial number and take it from there and build a keygen that does the same thing. I hope you've enjoyed today's video. I'm going to try and do one of these fairly regularly so that we can put our malware analysis skills to the test utilizing these CrackMe's, which are fairly similar to malware, perhaps a bit more challenging in some respects because they are purposefully meant to stretch your brain and make you exercise those muscles. I'll catch you next time. Thanks.